Good morning, everybody. Welcome to another episode of This is Automation Live. I'm your host, Corey Dallas, and we're happy to have you here today. We're coming off of our Introduction to Git episode that we just had yesterday, as a matter of fact. So we've got a nice double header in place here. And we're going to be talking about I/O today, specifically the X20 I/O family from B&R. This is a really exciting product line. It seems pretty bare bones, pretty simple, but there's actually a lot of really cool technology, really elegant design tied up inside these little I/O modules. So we'll be talking all about that. Coming up next week, we're going to be starting off with an episode about OEE, which is overall equipment effectiveness. This is a metric that you can use to measure kind of the overall state of your machine or your process. So we'll talk about how that's calculated, how it's useful, how you can use that to improve your equipment, and specifically in the context of the tools that B&R has and that exist in Automation Studio, we'll talk about how to implement that and visualize it on your B&R machine. So that will be a great episode for those of you out there that are excited about OEE and how to implement it. But for now, we're going to be moving back to the topic of X20. So when we talk about X20, this is exactly what we're talking about. This I/O module that you see on the screen here is called the X20 family. This comes from B&R Automation. And maybe the first question to kind of broach is why is this called the X20 family? It's pretty simple. Thankfully, there's a logical naming convention. The X20 just indicates that these modules are IP20 rated. So these are designed to sit on a DIN rail inside of a cabinet. That's what that IP20 designation is. So one of the key distinctions of the X20 family is this three-piece design. So when we look at a module, and I've got one right here that we can take a look at, you can see that it's clearly got three different pieces. So there's a darker gray module on the back, kind of a medium gray in the middle, and then this lighter gray terminal block. So I'll give you kind of a quick introduction to what these different pieces are, and then we'll talk about how they kind of come together to create this really neat little device here. So just a quick terminology introduction. The dark gray module on the back here is called a bus module. So this one here is a bus module. In the middle, this medium gray is an electronics module. So that's going to be where, kind of the brains of the I/O module sits. This is what makes it a digital input module or an analog input module, is the board inside here. And then lastly, we have the terminal block, this kind of lighter gray component here. Pretty self-explanatory. That's where your wires are going to terminate for your I/O. So maybe the most logical place to start is with the first piece being the bus module. So I'll quickly take this X20 component apart, and then we'll look at the bus module. So to do that, we push this little tab on the front, and our terminal block rotates down and comes off. And then there is a triangular kind of button there on the top that we can depress, and from there we'll pull that electronics module out. So there's some rails that guide that in, and we just slide that out. Okay, so now we've got our bus module kind of segregated, isolated. So we'll start talking about this guy now. One of the really interesting things about the bus module, I think you could see there, but I'll jump back and we can point it out, is there's a few different sets of terminals on there. There's two on the top here, two on the bottom, and then these four kind of in between them. So those are pretty intentionally designed, of course. So the ones on the top are bus supply. So that's power supply for the bus, the backplane. Then right below that is our bus data contacts. So that's actually the data backplane that's communicating between each of the different I/O modules and from the I/O module back to the PLC or to a bus controller. And at the very bottom, those terminals are the I/O supply. So the interesting thing that that design brings to the table is that you can actually have electrical isolation between your I/O supply and your bus supply. And why that could be important is, let's say I have a short on my I/O supply. That's certainly possible, right? Either a wiring error or something happens on the machine where maybe one of my outputs gets shorted. Okay, so instead of taking down my entire rack of I/O, if I have isolated my I/O supply from my bus supply, then I can maintain communications between the modules and actually know that, hey, this module is the one that's shorted. Yeah, I don't have my I/O power anymore, but I still have the communication power and I still have my communications up and running. So I can make sure that that error status is being communicated back and forth. So that's, one of the key points with the bus module itself is just that kind of integrated electrical isolation, giving you a really robust and kind of error-proof solution to be able to nail down exactly what's happening in your I/O rack when something goes wrong, instead of just saying, oh no, my entire rack of I/O is down and I don't know what happened. I don't know which module is to blame. I don't know which output on which module is to blame. But because of the way the bus module is designed, we're always going to know exactly what's happening. So that's a really, really nice feature that's kind of built into the bus module. Now, the other part of the bus module that I want to talk about is actually, if we were to take our bus module here and just rotate it to the back, this is actually where it mounts on the DIN rail. So you can kind of see that a DIN rail would fit right in here, where you can see that orange locking mechanism. So the nice thing about this is I've got this locking tab on top that I can flip up, and you can see the locking mechanism there. Let me try to get that. So that's actually what grips onto the DIN rail. What is nice about that is that if I need to, for example, change out a module or add additional modules, I never need to slide the entire rack off of the DIN rail. I can just unlock the ones that I need to take off and pull those out, replace them, whatever the case may be. It makes assembly much easier. So I could, for example, pre-assemble my I/O brick, like something like I have here. When I'm ready to mount that on the machine, I can just flip up all my tabs, slide it onto my DIN rail, and then flip all my tabs down, and now it's going to be locked in place. And then again, if I needed to add a module onto the end, I could just as easily, flip that up, slide it down, and lock it. So that locking mechanism is really, really nice for service and maintenance, but also just for commissioning the machine and assembling the machine. So it's the little things that make a big difference here. Now, this is, an example of what I was talking about. Let's say we have this big rack of I/O and I need to change out a module or a section or something like that. Instead of having to take every single component off and disassemble it, here I can just flip my tabs up and pull out that specific section that I needed to take a look at or replace or whatever it may be. And we'll talk a little bit more about replacing things in a minute. I'm sure those of you familiar with B&R are screaming at the keyboard that you don't need to even pull out the module to replace it, and that is correct, and we'll talk about that when we get to the electronics modules. So still on the bus module, this thing is small, but it has a lot of power. Speaking of power, we mentioned that the I/O supply is being passed through the bus module. So again, if we remember looking at our contacts there, the ones on the bottom, the two on the bottom, is our I/O supply. So when we look at the image that we have on the screen here, we can actually, using the bus module, different types of bus modules, create potential groups inside of our I/O rack. So our I/O may not all necessarily be supplied by the same power supply or potential. So why is that useful? Well, let's say in this case here, I've got 3 potential groups on the screen. I've got a potential group on the left-hand side for my inputs, the middle for my first section of outputs, and the far right for my second section of outputs. What if I wanted to, for example, put an e-stop circuit on just one group of outputs? Using this allows you to do that. So I can do a hardwired e-stop to the power supply for a certain potential group section within my X20 IO rack, and then I know when I hit that hardwired stop, it's going to bring down just that section of IO. Now again, what's coming into play here is our electrical isolation. So even though our IO supply is being broken up into different potential groups, our bus supply and our communications is still consistent between them. So when I e-stop my potential group, my output potential group, I still am getting communication. So I can actually know that that has been e-stopped, and also I'm not losing every module downstream of that just because I'm e-stopping a particular section. So again, the bus module is giving us a lot of really scalable opportunities to break out our IO into different potential groups. Again, whether that's breaking out an input group from an output group, or you want a specific section to e-stop on a hardwired e-stop. All of those things are possible with how it's designed. All right, believe it or not, we're still talking about the bus module. I think the last thing that we'll talk about on the bus module is shielding. So one of those things that comes up every once in a while is shielding cables. So like what you see here, maybe you're using some cable for an analog signal or something like that that has shielding, and you need somewhere to actually ground that shield. The bus modules actually have a little spade terminal on the bottom of them. So hopefully you can see that. So what you can do is actually plug in right here, and that is electrically connected to the pin inside here. So this is the grounding that's going to tie your IO rack to the DIN rail. So you can actually ground through this terminal on the bottom, and it'll be connected to your ground. So if we're looking at the shielding configuration on the screen, where we have a cable that has a shield on it, one possibility is to just take that shielding, put a spade lug on it, and plug it into that terminal. So there are other options for shielding on the modules, one of which is this clamp cable that you can get with your X20 systems. In this case, there's actually a braided cable here that still plugs into that same terminal on the bus module, but instead of just taking the shield directly to it, this is braided steel cable that clamps around the shielding on your cable. That's another way to do it. Additionally, there is the potential to use these shielding brackets. So kind of stepping away from the bus module here, but there are these shielding brackets that you can use to do very similar things. We're not going to talk too much about this, but just since we're on the topic of shielding, wanted to be fair and show all of the different options there. So you can use that for, again, either your again, like an analog signal, or even if you had a shielded Ethernet, you can use that there. And lastly, again, not a bus module specific thing, but you can also use like a top hat rail and use some of these clips to shield them. Again, very similar. Not all of those are leveraging the terminal on the bottom of the bus module, but just so you know, all the options to be fully transparent there. There's a lot of different ways to shield your X20 modules. Okay, so now we're kind of stepping up into the electronics module. So if we remember, when I disassembled the module not that long ago, I took my electronics module and I slid it out of my bus module. So this is what we're talking about when we say electronics module. So one of the key points here is that I have a pretty consistent design with my bus module. There's single width and double width for the most part, but really I can use, again, we'll put an asterisk on this, but I can use pretty much any electronics module with this bus module. So whether this is a digital card or an analog card, it's all very easy to just swap in and out. And there's a really large variety of these modules. We're not going to talk about that today, but just know that there's the standard, like what we call like gray IO, non-safety IO, temperature, RTDs, digital inputs, digital outputs, everything that you would probably imagine, as well as some 120 volt and 240 volt modules. So like what you see here inside of this rack, this red module indicates that it is an AC module. So you can actually have those AC digital inputs that you may need in your system. The other types of modules, again, just high level. There are some double width modules like what you see on the right hand side. So this one, for example, is a stepper motor module. So you can actually get some drives in this X20 form factor, which is a really powerful way to build out your system in a nice compact way. But yeah, the real key here is just the large variety of the electronics module, and by kind of taking all of the intelligence and locking it inside of the electronics module, it makes it a really scalable modular system from a design perspective. Okay. The other thing we'll talk about on the electronics modules is on the front of every module, you'll see there is a kind of black nameplate that has the model number. In this case, this is a dummy module, so it doesn't have much, but there's some diagnostics LEDs there. So if we look at the picture that we have on the screen here, you can see I've got a DI8371, so a digital input module, and an AI4622 analog input module. I've actually got a status LED for each channel on that module. So 8 digital inputs in the case of the digital input module, and 4 analog inputs. And on that specific analog module, there's also that green R and red E at the top. Those can give me an indicator of the status of the module as well. So they'll blink at different frequencies for different durations, and from that I can look inside of the Automation Studio help or in the data sheet for the module and know exactly what status that module is in just from looking at the front of it, without actually needing to communicate with it over software or anything like that. I can also tell the status of each of my channels. Again, just at a quick glance, I can know, oh, hey, module 3 is not seeing an input when I'm expecting it, or there's some error on that channel. So really powerful kind of at a glance diagnostics that you can get just from the front of the module. And each of these electronics modules is also communicating back to the PLC some status. So it's telling the PLC if it's okay or not, the status of each channel in some cases. So really powerful from a diagnostics and troubleshooting perspective. Now, one other thing that I wanted to bring up when we're talking about the electronics module is actually just how easy it is to change out a module in the field. So we looked at earlier using kind of the locking mechanism to make a change of like a big chunk of IO. But typically what's going to happen in the field is we have a module that gets damaged somehow and we need to replace it. So my digital output module has gone bad. I need to replace it. So the nice thing about that as far as a workflow is you don't really have to do anything to the rack. You don't have to take the whole card out to replace it. Really, all you need to do again is just open the terminal block up, slide the electronics module out like that, and then you could get your new module, slide it back in. So again, in most cases, these are hot swappable. You have to be a little careful with the AC voltage, but that means that again, your system can kind of be up and communicating while you make that module change, and the PLC will then identify if it needs any configuration or firmware updates and automatically send that. So again, from serviceability standpoint, the design of these modules is really favorable in that without kind of touching the rest of the system, I can just pull that electronics module out, swap a new one in. It's going to be pre-configured by the PLC. I don't have to flash any firmware or anything crazy like that. And then I'm up and running in a known machine state. I know exactly where I'm going to be because all my firmware matches and my module is going to match. And let's say I put accidentally the wrong module in. It's going to identify that in the PLC, and I can actually read that error either in the System Diagnostics Manager or through the PLC directly. And I'll also get on the front of the module a error LED. So really kind of foolproof design, which is nice, as we all know, in the heat of the moment when making repairs on a machine. Having foolproof design really helps to make sure that everything's getting back up into the state that we're expecting it to. All right, let's move down one more step to the terminal block, our trusty little terminal block here. Maybe the most underappreciated part of an X20 system is just our little X20 TB12 like we have here. Terminal block. There's actually a lot of intelligence, so to speak, tied up in here. Sure, it is just terminals and contacts, but there is intelligence in the way it's designed. So when we're looking at the module here on the screen, you can see that there's actually a little lock on the bottom of the bus module. So that little lock, we'll look at it here on the screen. That little lock right there is actually what holds the terminal block in place. So you can see the bottom part of my terminal block is actually going to clip onto that and then rotate up. So what's nice about that is you can see that my electronics module is now locked into place inside of my, between my terminal block and my bus module. So that prevents any errors as, accidentally unplugging this and causing shorts, inside my system here. I've got to actually remove the terminal block before I can do anything with my electronics module. So really kind of intuitive, foolproof design there again. Now, the other thing that is really interesting with the terminal block is kind of the whole point of a terminal block, right? But when I need to make a change, like what we just talked about with replacing an electronics module, I don't need to, unscrew a bunch of, Phillips head terminals and then worry about getting all my wires crossed when I'm trying to reinstall it. The workflow is really, again, just pop my terminal block off. It's going to have all my wiring in all the right places already. I don't have to make any change. I can just, set that aside somewhere, change my module out, and plug it right back in. So that is really, really nice as far as maintaining the existing wiring in any situation where you need to take that module out. And even for commissioning, you can, pre-wire these terminal blocks as part of a harness, for example. And from there, you're just clipping them in to the right module and you're up and running. So another thing with the terminal blocks is, and probably underused, honestly, this is a discussion that we often have with people that are new to these X20 modules, is on the terminal block, there's actually a small part on the bottom of the terminal block, and we'll just look at it here. So you can see this small hole there actually serves a purpose. It's not just a fun design element, and that purpose is for stress relief of cables. So when you're wiring up your X20 terminal blocks, like you see here on the screen, what you want to do is actually, with a cable tie, just connect all of your cables to the terminal block. And what that helps with is any damage to the terminals, or loosening a wire, damaging a ferrule, or damaging the wire itself, causing unintended consequences. Let's say someone opens the cabinet and accidentally pulls a wire, yanks a wire, something like that. That stress is going to be relieved on the terminal block instead of being transferred to the actual terminal itself, where it can be, a potentially sensitive connection. So that is a nice feature that if you're using X20 IO, I would highly recommend that you use. It can save a lot of headaches. Instead of, breaking a wire, ripping it out, you're just gonna tug on your module a little bit. So it's much more robust than the terminal itself. Okay, so we talked about using the terminal block in wiring harness, for example, or just in general. The idea may have popped into your head that, okay, sure, but how do I know if I have multiple of these off? What if I plug it into the wrong one? And that's a fair point. So another nice design feature, it's kind of a joint design feature of the electronics module and the terminal block, is keying. So there are actually small keys that you can get, like you see here, these small orange pieces, to make sure that you're putting the right terminal block in the right electronics module. So like you see here, you would just want to kind of have the opposite key on your electronics module as you do on your terminal block. And from there, you can see in the picture on the far right, only that specific terminal block is going to be able to close all the way in on the electronics module. So for example, if we had the keys in the two middle parts on the terminal block, then it would not fit into the electronics module. So this is a nice way, especially if you have maybe a couple critical components that you want to make sure aren't getting confused, a couple that get easily confused potentially on the assembly floor, or even for service purposes. You can use these keys to make sure that you're putting the right terminal block on the right module every time. And again, in a foolproof way, protecting against some potentially catastrophic errors if you were to accidentally place the wrong terminal block on the wrong module. So on that same note, I don't have a picture of this, but I'll do you one better and actually show it to you in person. So you notice on this red module, it's got a red terminal block. Now, the really interesting thing about that red terminal block is the keying of the red terminal block is actually slightly different. And when I say keying, I'm not talking about the keys on the back. I'm actually talking about this hook on the bottom. So I'll put these two side by side, and hopefully you can see there that they're slightly offset from one another. Okay, so what that means is that if I were to try to place my gray terminal block inside of my red module, I physically can't do that. So you can see that the key is not lined up on the bottom of my X20 module there with the terminal block. So when I try to actually clip that in, it just won't go. So it kind of blocks me from doing something silly there. And very similarly, taking my high voltage onto a gray module, my AC voltage would be an equally bad idea. And so I think this one illustrates it pretty well. There you can see it's offset just a little bit. So it's just off to the side there. So if I were to try to close it, those terminals actually don't line up. So you're gonna break something if you try to make that fit. But then if I were to try to put it on my red module, it slides in just fine. And same with my gray terminal block. Once I place the right terminal block on, those line up just perfectly and we're good to go. And actually what we're not showing today is any of the X20 safety modules, which are the yellow modules, but they are also keyed slightly differently on the terminal blocks. So really foolproof, kind of error-proof way to make sure that you're never going to accidentally put an AC voltage on a 24 volt card or vice versa, or that you're going to put a standard input module on your safety module or vice versa. Things that could have pretty serious safety impacts or machine functionality impacts. So you're really well protected against that just out of the box with the differences in the modules. All right, well, we've talked a lot about the X20 module. There's, believe it or not, even more that we could talk about, but this is all that we're going to cover today. So just to quickly recap some of the stuff that we talked about, we looked at really the three-piece design of the X20 slice and why that is so powerful, and kind of where that design comes from. So we looked at the few different modules that we have that make up that three-piece design. So again, if we're looking at our X20 slice, just our normal X20 slice here, we've got three pieces: the terminal block, the electronics module, and the bus module. Each one special in its own unique way, but when they come together, they're really powerful. So things like electrical isolation on the bus module, things like the diagnostics on the electronics module, stress relief on the terminal block, keying on the terminal block, a lot of really powerful design elements tied up in just this tiny I/O module. And we could have this same discussion about the X67 modules, which are the IP67 rated versions of B&R's I/O, and pretty much any other B&R product. Really, there's a certain elegance in the design in this module that I think speaks to a lot of the quality that B&R I know stands for, and a lot of the design methodology and design thinking that goes into making a product that really works for the OEM and for the end user. So really a strong testament to what B&R stands for, and what B&R's product quality and product design is all about. And hopefully this gave you a good introduction to the X20 IO module. It seems innocent enough at first, but hopefully now you know there's quite a lot going on inside these modules, quite a lot that you can do with them. And we'll plan to do another episode talking more about some of the specific applications, especially as a remote IO solution. So you can actually use these modules with a third-party PLC. It doesn't have to be a B&R PLC, and that can be a really interesting solution. So we definitely want to talk more about that in a future episode. But for now, I think we're going to sign off. So before we do that, though, I did just want to quickly tease again our OEE episode. So make sure you subscribe to the channel and set up notifications for this live stream so that you can get a little notification as soon as we go live, and that way you're not going to miss it. And if you don't mind, we really appreciate it anytime you like a post that we've shared on LinkedIn, or share it yourself. Leave a comment on the YouTube videos, leave a comment in the chat. We do look at all of those and they mean a lot. So thank you to those of you that have been doing that. Really appreciate it, and really appreciate all of the support from all the viewers out there. If you need to get in touch with me, or just want to get in touch with me, you can do so on LinkedIn. Contact information is in the description below, as well as through YouTube. Again, just leave a comment and we'll make sure to respond to it. Hope you enjoyed this episode talking about X20 IO from B&R, and we will see you next time on This Is Automation. Thanks again.